all we're doing is Pythagorean theorem. So I've got x squared equals 5.4 squared plus 8.3 squared square root. I just put it in my calculator just like that and got, what did I get? 9.90. Second one, same thing. X squared equals 4.6 squared plus 3.9 squared. Square root it. X is going to equal 6.03. Okay. 3, just a little different. I've got x squared plus 3.7 squared equals 6.2 squared. So subtract 3.7 squared. And I've got x squared equals 6.2 squared. Subtract 3.7 squared. Square root them. Yeah, I didn't figure out what 6.2 squared and 3.7 squared is. I just left them as a squared and put in my calculator just like this. 6.2 squared minus 3.7 squared. Then I didn't have to deal with all the decimals. Okay? And x is approximately equal to, is that number 3? 4.97. 4.97. Number 4, whew. Okay, x squared plus 1 squared equals 5 squared. So x squared equals, subtract 1, 25 minus 1. So x squared equals 24. This one was easy just to simplify. X is approximately equal to 4.90. Okay, let's see, number 5. X squared plus 5.4 squared equals 6.6 squared. Subtract 5.4 squared. And I get x squared equals 6.6 squared. It's 5.4 squared. Square root. And x is approximately going to be equal to 3.79. Is there any questions on this? You guys know how to do the Pythagorean theorem, right? We're okay with it? Everyone at home okay? Awesome. And then number 6, let's see. X squared plus 5.9 squared equals 7 squared. So subtract 5.9 squared. So x is approximately equal to 3.77. Okay, any questions? Are we okay? Not too bad? Okay, we're going to start trig today. Just a short, sweet reminder for trig. Because that was the easiest one to do. Out of the 2 we haven't done yet that I've done in the past. So that's what we're going to do today. Do I need to pause for a second? Exhaust. Did I go too fast? Do I need to go back to any of them?
Yeah, for the first one.
Those ones? Okay. Oh, I haven't even made my screen bigger yet, have I? There we go. Okay. So we're going to talk about trig. Right triangle trig is a branch of math that deals with the relationship between the sides and angles of a right triangle. You guys already know that, right? We're just dealing with right triangles today. We're not going to do law of sine, law of cosine. No. We're just dealing with right triangle trig. Okay, so the trig ratio is the ratio between the sides in a right triangle. So sine, if we're talking about, so sorry. Can't breathe in this. I'm never going to deal with my right triangle. So I want to find an angle I'm going to deal with. If I'm going to talk about this one, I'm going to call this theta. I'm going to write that up here. It's the Greek letter theta. Okay, they just use it all the time when they're dealing with trig instead of calling it x. Sides are usually x, y, and z or whatever. And then angles are some Greek letter. And we're going to use theta most of the time. okay? So if you see that little 0 with the little line through it, it just means theta. Okay, and so, Matt. Sine is, if I'm looking at this angle, and this is my reference angle, it's called a reference, I'm going to spell it wrong. Oh, I didn't, reference angle. That's the angle that I'm looking at, and this is my angle that I'm looking at this time. I have 3 sides of my triangle, right? I have the side opposite that angle where I can draw an arrow through the triangle. This is the side opposite. Okay? And then, of course, I have my hypotenuse, which we all know, right? Hypotenuse. I think that one's spelled right. And then we have this side here. And this side is the side adjacent. It helps make the reference angle with the hypotenuse. And that's how I think about it. Adjacent in English means, right, next to. That's what adjacent means, is next to. So it's next to the angle that I'm my reference angle. So this is my adjacent side. So, and I think really in trig, that's the hardest part, because I think most of you guys can do sine, cosine, and tangent. It's just deciding what side is opposite and what side is adjacent. And that's where I found that the difficulty has been through my experience in teaching trig, is deciding which side is opposite. So if you understand what adjacent means and opposite has to be through the triangle, you'll be okay. So who knows what sine is? Does anyone remember what sine is? No? Okay. Sine is opposite over hypotenuse. Right? Op over hypotenuse. And then cosine is, I'm really going to spell this wrong, adjacent over hypotenuse. ADJ or HYP. And then tangent is TOA, opposite over adjacent. Okay? Just the relationship between the sides and what's it means. What's it means? Wow. Okay, what it means. And again, we just talk about, the next little part just talks about opposite and adjacent depend on what angle I'm referencing, my angle of reference. The side adjacent to an angle is the leg of the triangle that helps form the angle. And the side opposite to an angle is the leg of the triangle that does not help form the angle. So a different way of thinking about opposite, right? It doesn't help form the angle. It's the one that I have to draw actually a line through the triangle to get to. Okay, so today, all we're doing today is just finding these relationships, and that's it. So we're just going to find these relationships from a triangle and finding which angle that they're talking about, okay? So I think that's all you have to do on your homework too. I mean, that's it. We're not doing any calculations. We may have to simplify a fraction. Reduce all fractions. Pictures are not, just so you know, in all trig, pictures are not drawn to scale, so just take it lightly. So this part right here tells me what angle I'm referencing. So on all 3 of these, I'm looking at angle A. So I'm just going to go ahead and mark angle A so I know that that's the angle I'm looking at. There's my angle of reference. Okay? So I know my hypotenuse is here. My opposite is opposite. I can draw an angle through the triangle. So this has got to be opposite. And then this is the side adjacent. It makes my reference angle. And this is my side adjacent. Now that I've labeled my triangle, I can just go ahead and do my sine, cosine, and tangent, okay? So sine is opposite over, I'll write it out this time. So opposite over hypotenuse, which is, my opposite side is 12. My hypotenuse is 15, and then I simplify that. 3 goes into both of them, right? So that would be 4/5. 4/5. Questions? Not too bad? Is that okay? You guys at home? Cosine is Cosine is adjacent over hypotenuse. I should have just written this underneath it. Oh, well. Adjacent, my side adjacent is 9. My hypotenuse is still 15. And 3 still goes into both of them. So this would be 3/5. Beautiful. And then tangent is opposite over adjacent, which is my opposite side is 12. My adjacent side is 9. 3 still goes into them. So this would be 4/3. And that's all we're doing, finding that relationship. Okay. So we'll look at the next set when you guys are ready. So if I look at my next triangle, I'm looking, what's my angle of reference? My angle of reference is whatever's in these little parentheses, which happens to be angle F. Oops, dang it. Try that again. Angle F is my angle of reference. I can label them again, of course. Here's my hypotenuse. Here's my side opposite. And to make my angle is my side adjacent. So sine is opposite over hypotenuse. My opposite is 16. My hypotenuse is 20. And then I simplify it. 4 goes into each of them. So that would be 4/5. Beautiful. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent is 12 over 20, which simplifies to 3/5. And then tangent is opposite over adjacent. So opposite is 16. Adjacent is 12. 4 goes into both of those, so that would be 4/3. Questions? Not too bad? Pretty easy? Awesome. Okay, and then on the last one we're going to do together. Ooh, we have 2 things to do. Okay, so first one we're going to do, find angle A here. Angle A is my, my reference angle, so I'm going to do angle A here. So, and I know that sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So sine is going to be 3/5. And cosine is going to be 4/5. Notice I didn't label my triangle this time. Is it okay? Yeah. Do I have to? No. If you need to do it, then yes, do it. Yeah? Okay. And tangent is opposite over 3/4. Okay. And now for the second one, we're looking at angle C. So here's my, for the second set, here's my angle of reference. And sine is 4/5. Cosine is 3/5. And tangent is 4/3. Questions? We're okay? All right, I'm going to have you take the next few minutes and answer. Oh, you know what? You don't have to do number 9. Let me cross that one off for you guys. Sorry. Do all the questions A, B, C, D, E, and F. Well, let's just do them a little bit, half a page at a time, so you guys at home can see it. So let's do A, B, C, and D. Here we go. We're finding reference angle Q. So sine of Q is 12/13. Cosine of Q is 5/13. And tangent is opposite 12/5. Beautiful. Okay, M, so now I'm looking at angle M, and sine is 10 over 26. That would be 5 over 13, 5 over 13. Cosine is going to be 24 over 20. Oh, that's not a 24. Wow, let's try that again. 24 over 26, so that should be 12 over 13. Yeah. And then tangent opposite, 10 over 24 should be 5 out of 12. Questions? Is that good? Okay, so see, all the rest of them we're looking at doing two different angles. So the first one is going to be V. So this one should be pretty easy because we've done a whole bunch of them. So sine is 3 over 5. Cosine is 4 over 5. And tangent is 3 over 4. And then we're going to look at T, which is this side. So sine is 4 over 5. Oh my gosh, did I write 5 over 4? Sorry, that should have been 4 over 5. I don't know why I wrote it backwards. And then cosine should be 3 over 5. And tangent should be 4 over 3. Okay, beautiful. And then I think we were doing D. That's the fourth one that we needed to do. So angle G is this one right here. I'm going to write it small because it's teeny. Sine is 40 over 41. Cosine is 9 over 41. I don't think any of those simplify. And then tangent is 40 over 9. And then we're going to look at angle I. So that should be 9 over 41. And then cosine should be 40 over 41. And tangent of I should be 9 over 40. Did you get them all right? Nice job. Okay, two more. All right. So let's see. What angle are you looking at? F. We're looking at F. Whew. Sine would be, what is sine? 15 over 17. And cosine would be 8 over 17. I like the ones where I don't have to simplify. And tangent's going to be 15 over 8. And then we're going to look at angle H. So sine is 8 over 17. Cosine is 15 over 17. And tangent is 8 over 15. The second set should be really easy after you get the first set. Has anyone figured it out yet? Why? It's really easy, right? Sine and cosine are what? Flipped, and then tangent is the inverse of it, right? So once I have this set's really easy to get. So sine, R, where's R? Here's R. So sine is 35 over 37. Well, I made these easy. You guys don't have to simplify anything. Cosine is 12 over 37. And tangent is 35 over 12. And then angle T, we've got 12 over 37, 35 over 37, and 12 over 35. Boom. That's it. Okay.